Hello, everyone. Thank you for joining us once again for our weekly briefing on preventing and managing COVID-19 in the workplace. This is Karen O'Hara. I'm the Director of Marketing and Communications with WorkCare and your moderator for today's session. For those of you who are joining us once again, you'll be happy to know this is our 45th consecutive week. And if you're brand new to this event, we welcome you. I'm sure you'll find it very informative. The session is being recorded and you will be on mute during the webinar. Please submit your questions using the Q&A function in Zoom. We answer as many questions as we can at the conclusion of the formal remarks, which typically last about half an hour, and then we reserve 10 to 15 minutes at the conclusion to answer all the questions. Any remaining questions we answer in writing and post on our website on the COVID-19 page, which you can find at workcare.com. You can find the recording of today's session and all past sessions on our YouTube channel, and it should be uploaded within a day or so. I'd like to introduce you to our presenter, Anthony Harris, MD, MBA, MPH. Dr. Harris is board certified in occupational medicine. He's WorkCare's Chief Innovation Officer and Associate Medical Director for On-Site Clinical Operations. He's also our lead clinician for WorkCare's COVID-19 response. So I'm happy to turn it over to him. Thanks again for joining us.
Excellent. Thank you, Karen, and thanks everybody for joining us once again. We are excited today, our 45th consecutive presentation. We're going all the way to 52. We're, full year. We're not going to slow down, but we are going to celebrate doing this for a full year without missing a beat. So today we're going to jump into some updates that are key regarding both vaccination, but more importantly, some of the events that have occurred over the last week in regards to variants that are making their way in the popular media. And let's see what impact is prognosticated in regards to the impact from these variants across the board. So let's get started. If you're joining us for the first time today, our format is pretty straightforward. We'll go into a clinical update, followed by pathology and some microbiology. Epidemiology is next, where we'll look at the numbers macroscopically and microscopically, US and beyond. And we'll go over some prevention in terms of trends, as well as what we're doing at WorkCare to help with your strategy to prevent injury from COVID-19 ultimately, because that's what we're talking about, and morbidity from COVID-19 through workplace transmissions. So let's jump into our clinical presentation for today. Now, I don't mean to cause alarm, right? But I do want to make it a point that we address the inevitable outcome of COVID-19 for some people. And at this point, it's becoming a large number of people, and that is death, right? We want to talk about death more because we're going to see a lot more death, unfortunately, here in the US as a result of the transmissions that we're seeing across the board. So what do we want to talk about in regards to the deaths that we're seeing? So the first thing we want to talk about is this study that was done and reported in JAMA. This was recently published just less than a month ago, or just about a month ago on December 17th. And this article specifically is addressing proportionally as well as cumulatively looking at the causes of deaths, the leading causes of death in the United States. And we reported on this about maybe 2 months ago, perhaps. And we talked about COVID being the third leading cause of death. And unfortunately, as of December, mid-December, we understood now that COVID-19 is the leading cause of death in the United States. So what does that look like? How do we even wrap our minds around that? So if we talk about the mortality rate of COVID-19, it's equivalent to September 11th, 2001, attacks happening, and that's 29,000 lives, almost 30,000 lives occurring every 1.5 days in the US, right? It's equivalent to 15 Airbuses, 320 jetliners, and that's crashing with 150 passengers every day, right? So those are sobering numbers. And we want to get the message out that This virus is impacting many families, many communities in a dramatic way and causing deaths that are preventable, could have been prevented. And we'll talk more about those studies that have examined the prevention as well. So let's get into looking at specifically the leading causes of death that now COVID has surpassed. So for the age group of 35 through 44, we can see that it's more likely that you will die from COVID than car accidents, transportation accidents at 93.8% compared to COVID at 109%. We can see for COVID-19 specifically in the age range of 55 to 64, heart disease is nearly halved in terms of the number of people that are dying from COVID in this study. Again, we have to emphasize the importance of prevention to our general public so we can prevent these numbers from increasing beyond what we're even seeing now. So when we look at 75 to 84, the study showed that it's more likely you're to die of COVID-19 than, again, these other leading causes of death: heart disease, malignant neoplasms, and a respiratory disease. So we have to understand this, digest this, and communicate this back in a continual way with our workforce, because unfortunately we're not seeing the numbers substantially increase in terms of vaccination participation. We'll touch on some more of that here shortly. So when we talk about the inevitability for many at this point that are dying from COVID-19, this study specifically calls out that the transmissions that have happened here have been made worse by poor action early on here in the US from political leadership, right? And from municipalities. And so it speaks to those aged 35 and older. Now, again, number one cause of death for them is COVID-19, and it could have all been prevented. That is chilling in regards to our prospect looking forward, right? If we don't have course correction, what numbers are we likely to see in terms of deaths? And if we go back to some of the early prognostications that came out of the UK, that also was mirrored by studies here in the US, looking at the end of the day, how many deaths are we likely to experience from COVID, which was 2 million deaths. We are on our way, ladies and gentlemen, if we don't have course correction to hitting or perhaps getting close to some of those numbers, because we're seeing an escalation here. Let's look at some of the drivers behind death in regards to transmissions. We're going to focus back in on one of our favorite terms here to study in terms of understanding the infectiousness of this virus, which is the R0 number, RT. It's the reproductive rate that we've talked about before, that we've seen vary between as little as 0.5 to 0.8, all the way up to 5 estimates in places like New York, California, Florida. This study in particular comes from CDC data, and it also looks at a model that puts forth a range in which R0 is likely to exist in these various states, all 50 states, okay? And we looking at this over time. Right now, this is the most current data in the most current ranges, what you're seeing on your screen right now with regard to where states stand with the R0 number. So just to refresh for some of you who may not be familiar with R0, we're talking about the number of people who are likely to contract COVID-19 from a single person. So if the R0 is above 1, that means more than one person is contracting per individual who has COVID-19. Again, an R0 of 5 means 5 people will contract it from one person. These are person-to-person contacts. You can see Hawaii there at the high, having the highest potential R0. Again, the R0 here of 1 suggests a substantial risk for increased transmission. You can see which states are above 2, and again, Hawaii being above 4 even based upon current data. Now, if we take a step back and we look at and pick on my home state where I'm from, where I grew up, Florida, we can see the trend over time, and you can look at this on each state, trend over time of what the R0 has done in that particular state. And we want to look at 2 points here. When the shelter in place started and the dip that we saw in the R0, and when the shelter in place ended and the escalation we saw in the R naught, right? And we knew that would be likely the case in those states that took away the restrictions during that period in time. And we saw the R naught again go down below 1 here in Florida based upon historic data and this model combined. And we see it go back up over 1 over the fall of last year when we saw the spikes. And then we see it dip down again below. Now we're going to zoom in to the right side of this chart, because we don't want you to think that Florida is not experiencing increased risk for transmission. If you look at the range here, we can see that yes, indeed, R naught in the range that it exists is above 1 in some cases. And so this is a confidence interval, just like any model that puts forth a number that's not 100% historic cases in terms of the data. However, these numbers and estimates are based upon historic trends. So we want to continue to look at the impact to each state. We're going to pick on Florida a little bit more during this talk today because they are seeing some emergence and they are leading in some indicators that aren't great. So let's get into the numbers as we look at our epidemiology. So in the US, where do we stand? And 2 weeks ago, we stood with on a 7-day average daily rate of cases at 64.5. Again, over 20 million cases 2 weeks ago. That jumped to 22 million, almost 23 million last week. And we jumped that number of cases per 100,000 to 74.8. This week, we're down a little bit, 62.8 in terms of cases per 100,000. Obviously, our total cases have gone up to 23 million, almost 24 million. Now, one would speculate, oh, we're seeing a little decrease in the case rate per 100,000. That's a good sign. What CDC says, however, is this data likely is showing a dip only because of, or likely contributed to, lagging data from reporting as a result of the holiday season. So we're looking for this number to get caught up in terms of reporting, and we'll likely see this number balloon back up over the coming weeks. So we'll continue to pay attention to that. If we look at the death rate in terms of deaths per 100,000, we were at 0.8 with over 350,000 deaths 2 weeks ago, jumped to over 1 with approaching that 400,000 deaths last week. And we're right at that 400,000 mark now this week, still at that rate of 1 per 100,000. Again, COVID, as we mentioned, reported in JAMA, leading cause of death in the US for 35 and older. Looking then at the confirmed cases in the US compared to our neighbors, comparing to the UK here, total cases, we know we're still leading by far and away in this regard. We know that if we zoom to next week, we can see our performance and dip there a little bit on a 7-day average. If we look at per million, however, we understand we're not the worst off in regards to a population-based number, but we're up there still right under the UK. And that was 2 weeks ago. This was last week. That was last week, and this is this week's data. As we can see, we're still kind of neck and neck with the United Kingdom. If we look at deaths, total deaths, you can see the impact that we've talked about here briefly compared to the United Kingdom. Break that down per million now, and we can see United Kingdom and Germany are ahead of us in regards to their impact from a mortality rate. And we'll continue to watch how their numbers continue to go up, unfortunately, over time. If we look to the numbers today, Germany and the UK ahead of us. So our trend in particular was trending up historically, dipped a little bit. We're dipping a little bit again, but again, we're likely to see this number, because of reporting delays perhaps, still go back up the following weeks here. Total number of tests on a daily average, 7-day rolling daily average. We've seen this number much higher than what it is now. And we see last week where it was and this week where it is, just over the 1.3 million per day on a 7-day rolling average. And hopefully, it's unlikely now that we see this oscillations and kind of a plateau of our capacity right now. Unlikely we're going to see dramatic increases in tests for the type of tests that are being performed by far and large. We'll revisit testing. We'll revisit some of the strategies that we're suggesting and launching with our clients, but we want to pay attention to, is this number going to move if we approach new strategies on testing? The test positivity rate, however, in the United States continues to climb. Not surprising because our prevalence is climbing. We look at this from last week, where we stood behind Germany there and where we stand today. Still small oscillations, but finally crested that, we crested the 15% positivity rate, and we're likely to see this continue to go up in the midst of vaccinations that are occurring because of the increased rate of transmissions that we're seeing. So now let's jump back to the vaccinations. Let's look at where we stand today compared to last week. If you recall, we were about a third of distributed vaccines versus administered vaccines. So if we zoom forward to today, 31 million distributed doses in the US. If we look at administered doses, half of that now for administered doses. So we're catching up a little bit in terms of percentage. That's a good thing, obviously. If we look at then the total number receiving one or more doses, that 13 million mark versus 2 doses, those who have completed the series is only 2 million. So we know logistics plays a role. We know that access plays a role. And we have not yet rolled this out to the general public in most, if all states. So we can anticipate this number increasing in terms of percentage over time as we have these mass vaccination locations like Disneyland in California and other venues now. From a perspective of logistics, we have positive news in regards to private industry like Starbucks. Schultz, the CEO of Starbucks, now partnering with the state of Washington to help with logistics, reportedly. And we hopefully will see, with the change in administration as of today, more private industry hopefully coming to the forefront, partnering with public entities to help with distribution logistics, and we can accelerate our administration of vaccinations. We can track so the government is tracking, CDC is tracking, FDA is tracking the actual vaccines that are being administered, Pfizer and Moderna. And we'll talk about this in a week to come, and next week, on how we can help in that regard, with basically a passport process for your workforce, which is in the works within Work Care, and will be live very soon. So when we talk about the overall picture globally with vaccinations, we can see that the US is doing well with total number of vaccines administered, ahead of China, UK, and a number of our partners across the pond. If we look at this and break it down per 100 of doses administered, and that was last week's numbers with, 2 weeks ago, where we were with administered doses. If we look at last update to this week, so again, last week versus this week, we can see where we stand today with total number well over the 800,000 on a 7-day rolling average. But when we compare on per 100 people in the population, we can see UAE is well ahead. The United Kingdom is ahead of us. So we have some ground to make up in regards to access to the vaccine and the number of people that proportionally that we're able to vaccinate. And that was last week. This is this week. We're still in that same position, actually falling back a little bit compared to the United Kingdom a bit. So let's talk about some of the trends that we see playing out and what that impact will be for us, and the variants are what we want to get into a little bit more, the variant threat, right? We've touched on what a variant is in the past. We've talked about how the virus mutates. We've talked about the spike protein and the importance of that in terms of binding site for our receptors on our antibodies that form the immunity to the virus itself. And we want to talk about now the variants that are at the top of everyone's mind, perhaps, which is the UK variant. And we won't get back into the science of the UK variant as we have before, but we want to look at the epidemiology of this variant in the US. We can see in terms of headlines, obviously, Florida now is the leading state for this variant in terms of total number identified in the populace of positive individuals with COVID-19. So if we look at the map of the US, this variant is named B117, and this is comes from a particular clade. Recall that the clade is the family of mutations that have happened since the beginning of this pandemic, and we're specifically identifying this genetic abnormality or genetic mutation in multiple states at this point. You can see them highlighted in the dark blue. And if we look at then, again, total cases, only 122, right? So we're not talking a huge number of this variant in the population at this point in time. If we zoom in into Florida, that number is 46. Again, they lead all other states in this particular variant. So what does that mean? That means that this variant may likely become, as a result of its propensity for transmissibility above and beyond what we've seen before, play out to be the most dominant form of COVID in the US. Now, is that a particular threat to us? We'll get into that a little bit more. So when we talk about the variant, again, coming out of England, and this being a new variant identified beyond what we saw with the UK variant, this variant is estimated to have increased transmissibility, but decreased severity. Okay, and so we want to talk about that, particularly because we need to cull or allay the fears of our workforce that this variant is going to have a dramatic effect in regards to morbidity or mortality. Right, we're just not seeing that play out thus far, and not likely to. Right, and if we look at then the percentage of this particular transmission rate of this virus mutation compared to previous versions or clades that we've seen, this virus is likely to be 56% more transmissible than the previous versions of COVID-19 or SARS-CoV-2. So that is important, right, to talk about. The transmission rate we might likely see go up as this continues to play out to be the dominant. Some estimates are that this will be the dominant by March in regards to the US form of COVID-19 that we see. But the good news is that this likely is not going to, again, cause more severe disease, and it is likely to be captured from a immunogenicity standpoint by immunity given imparted by the vaccines themselves, both Pfizer and Moderna, the approved vaccines. So we have evidence of this in terms of this being a lesser severe, more transmissible virus, and we want to allay the concerns and fears that it's going to lead to more morbidity and mortality. Now, overall, because of, again, there's a difference I want to draw here. There's a difference in severity, and there's a difference in the epidemiology, the numbers of what we'll see play out with morbidity and mortality. So will the death rate go up as a result likely of this mutation, this UK version of the virus? The answer to that is yes. The mortality may go up. It's because of the prevalence and incidence going up, being accelerated or increased as a result of the increased transmissibility of the virus itself, right? So that's important to think about. That's important to communicate, because we want everyone to hopefully put away their COVID fatigue again when we talk about potential impact, so that we can protect each other with the protections that we have had in place, and hopefully keep that R naught number from climbing as a result of this new mutation becoming a dominant mutation in the US. So when we talk about a new mutation, California has identified in LA County a mutation that we just don't know too much about, right? And there are some early studies that have been published that speak to that variant potentially being resistant to a vaccine, the Pfizer and the Moderna vaccine. Now, we have scientists have studied this vaccine, first identified in Denmark, and, oh, excuse me, I said vaccine, this virus, identified in Denmark, and that was back in early last year, back in March of last year, right? And we titled this L452R, okay? Identified in Denmark back in March, and California in as early as May of last year. So it's not new to California, it's new to the media, right? In terms of publicly kind of announcing this particular strain as a potential threat. But again, we want to allay people's concerns in that this has not been conclusively identified as a vaccine-resistant virus. Okay, so at this point, there's more studies that need to be performed, as this professor Charles Chu at UCSF down in Florida, and speaks to, more is needed, right? And so we'll see how this plays out. But again, we haven't seen anything dramatic as a result of this being in California since May in regards to the R naught number, as well as in regards to the severity of illness, disproportionately so in California. So we'll see what new research brings us, and we'll talk about it here in this venue. So let's look at now the national forecast, right? So we're talking about virulence, we're talking about mutations. Now we need to talk about prognostication of what this may all mean and represent for us moving forward throughout 2021. Now, we're not going to go to the end of the year in this presentation with regard to projections, right? Haven't read any studies yet that have been worth presenting that trail this all the way to the end of 2021. However, we can look at the data that is published from multiple sources from the CDC that identifies different tracks that may play out here for us in regards to the impact of total number of deaths as well as total number of cases. So if we zoom into this, we can see the forecast for new weekly deaths be as high as 25,000, right? And if we go further from that, we can see several projections up over 30,000 deaths on a weekly basis. Certainly, if we look at the combined forecast here, we can identify those trends more clearly. A little lower, right under that 25,000, right around 23, perhaps 22.5 thousand, but still a substantial number of deaths on a weekly basis will continue to play out moving forward, taking into account the variances that we've identified in both strains as well as interventions, right? The vaccine and how it plays out. So again, we're going to continue to be hard hit by COVID moving forward, which is why we have to have a strategy in place to help prevent transmissions both at work and hopefully keep workers more mindful to prevent transmissions in the community. So let's talk about that. What can we do in the workplace to help identify those individuals who are contracting this new strain that's more communicable, right? And what can we do to prevent transmissions in the workplace? Now, you may already know the answer to what I'm about to say, because we've been saying it for a number of weeks now, but we want to bring it home because it's now a real-term solution that we can present, and that is pool testing surveillance. And we know that the pool testing surveillance can be a strategy in which you can capture both the asymptomatic individuals who still may show up to work and not know they have COVID-19, which makes up approximately 65% of the population in terms of transmissions at this point in time. We also can capture those pre-symptomatic individuals who have yet to come down with symptoms and haven't realized they have had an exposure and can transmit the illness at work. So we want to talk about what this looks like. Again, we know, and we presented last week, WHO said we will be dealing with throughout all of 2021, COVID-19, and there won't be any return to normalcy until such time. So pool testing, again, will help us do two things. We will capture disease where it's otherwise not presented in a way that we can keep people out of work appropriately that have illness. And two, we can bend the cost curve with this methodology for performing these type of PCR quality tests, right? And so the partnership that we forged at WorkCare allows us to take a sample of individuals in pools of up to 24, all right? I presented this, I believe, almost 6 months ago. And at that point in time, it wasn't near term in terms of being able to deliver this solution. And now it is very real. We've been doing this, or this partner has been performing these at a rate and capacity of 20,000 tests a day, right? And so because of that, we can now do surveillance testing at a fraction of the cost, taking 24 people in a pool, identifying who's positive in that pool. So these are multiple pools. In this case, we have 16 pools of 24. This is hypothetical of workers. That gets each pool is then identified as positive or negative. If it's positive, then the pool shrinks to two individuals, and each sample is tested in this fashion, identified which of these different groups of two may be positive. And from that, an important inflection point occurs. So it goes from, and we've talked about this previously, this process goes from a surveillance program with testing and retesting the same samples to a diagnostic test that can identify one individual who needs to isolate appropriately, right? And when we talk about that level of diagnostics at a fraction of the cost, then we're talking about an opportunity to really do primary prevention in the workplace, capturing these asymptomatics and looking at this methodology a little bit further. Again, we can do this on a weekly basis. We can do this on a bi-weekly or even multiple times in a week because we've bent the cost curve substantially, right? And when we talk about looking at the sampling method for performing this type of test, it's not onerous. It's very straightforward in that it's a saliva test. We have shipments to you, the employer, that once you have it, you can distribute it to your workforce appropriately to do surveillance testing. The saliva sample is captured in a small little container here and shipped back. And then the pooling happens on the back end of this process, right? You don't have to do any admixing or anything up front on your end, but again, simplistically ship it and within a quick turnaround, and as soon as 24 to 12 hours for the secondary testing, we have actionable results that we can provide back to the workforce so that we can prevent those asymptomatics, pre-symptomatics from potentially spreading illness. And it's still happening with large companies. We know this, right? We have partners that I was just on the phone yesterday with, just reported their 115th reported case at a site that only had less than 1,000 workers, right? And so again, the impact is dramatic. If we can do primary prevention, it's going to pay off in regards to ROI dividends for sure. So the process being straightforward, we won't get into the details of all the nitty gritty behind it, but we want to communicate that this is 100% positivity rate in terms of sensitivity and specificity at 95%, right? So we want to make sure we're using quality. We are in this case, it's PCR, and we have now the capability to deliver this at scale with our partners. So with that, in terms of strategy, we'll open it up to questions, and I'm ready to hear what you have to say. Thank you so much.
Thank you, Dr. Harris. One question about pool testing. So if one of the 24 is positive, then you retest the entire group in twos? That's how, so you have to retake another test?
Yeah, so
you read it. Okay.
Yeah,
so review again.
You betcha. So what you're seeing here again is a process that only requires one sample to be taken from an individual. So that same sample your worker has provided is retested. And again, the benefit there is obviously we save on time. Historically, when we first started talking about pool testing many months ago, you had to retest an individual in terms of getting another sample from that individual. It was time consuming. And that's why we talked about a process called adaptive pool testing, which used a stochastic method for determining who was positive in a group from a particular sample, which would save time. But it would also have limitations in terms of the size of the pool, and because of increasing prevalence, lose its impact or efficaciousness to do that adaptive pool testing methodology. Now that the sensitivity and specificity, particularly the limit of detection using PCR technology, has increased so dramatically, we can now detect in these pools adequate RNA from the virus itself, and we can consistently detect that in the same sample without having to receive a new sample from the individual. So we go from 24 in a pool, and we retest. If that pool is positive, then we retest all those samples in that pool in groups of two. Again, a cost saver. And then finally, we once we get to that point, we are able to perform a diagnostic test, again on the same sample provided, to understand who out of the two in that group or that small pool is positive for COVID-19.
Okay. So for those who haven't done the saliva test, I took one and it's super easy. I found it really simple to do, to mail in. Now, it's a pretty low impact methodology. Question about results. What is the approximate probability of getting false negatives tested while they're symptomatic using PCR and also for rapid tests? The approximate probability of false negatives.
Sure, it's all predicated on that particular test accuracy, sensitivity, and specificity. We know that some PCR tests have as high as 95 to 98% sensitivity and 100% specificity. In this case, with the PCR test of this pool process, the sensitivity is just that 95% and specificity 100%. When we talk about rapid testing, there is a significant variability to the tests that are available and EUA approved as well. And some tests have sensitivity and specificities in the 95 percentile and some don't. So it really depends on which test you're utilizing, but there are some very accurate tests that have been utilized, we've been using for many months now without problem.
Okay, a couple people are asking about the variant and the effectiveness of the vaccine against specific variants of the virus. Could you go over that again? I know we've talked about it in previous webinars.
Absolutely. So the sensitive or the ability for our antibodies to recognize the virus and then appropriately defend our body against the virus is all predicated on the receptor binding site, all right, the RBS. And the RBS is what is mutated when we're talking about the spike protein in particular from what we've seen over time since day one in Wuhan, China, where there was two strains, S and the N strain, right? What we've also seen over time when we talk about the different clades or families of mutations is that we have not experienced a mutation significant enough at this point in time in observed studies that causes our immune system not to recognize the SARS-CoV-2 virus. So put another way, even with the mutations and the variants that we've seen, our antibodies should still recognize that binding site, identify and attach substantial enough to prevent illness. And these are called neutralizing antibodies, is what the immunity is imparted by the vaccines themselves, and as well as obviously recovery from COVID-19 with natural immunity.
Okay, for those of us in California, we're wondering about the Moderna vaccine. There appears to have been a certain batch of vaccine where there's been a higher number of adverse reactions. And wonder if you could tell us a little bit more about those events.
Unfortunately, I have not read any recent evidence or evidential study or anything pointing to why those events have occurred, right? We spoke to the Pfizer and the Moderna vaccine having a component to it that caused increased anaphylaxis responses compared to what we traditionally would see with vaccines that have been used for decades, right? Where we're talking 1 in approximately 11 million would have an anaphylactic reaction to a vaccine. We've seen as high as 10 to 12 in a million with the Pfizer and the Moderna vaccines. And as far as studies have gone, they're still studying and looking at what components may be driving it. But we talked about the polyethylene glycol or PEG as that component, which could be leading to the side effects. As far as California and these specific batches, I don't have any particular data that I can share as to why those occurrences have. But we'll dig into it, right? If we see evidence of it, we'll present it in the weeks to come here for sure.
Yeah, I think they're still trying to figure it out here because I live in the county adjacent to where that vaccine was administered, and I heard a report on it this morning. They're still looking into it, so keep an eye on that. Here's a question about breath-based testing using gas chromatography. Does this look feasible to apply in the workplace as an on-the-spot testing methodology for door screening?
So actually, there is a company that utilizes gas chromatography for breath-based testing. They've launched it with large kiosks, and they're large, about 6.5 feet tall, if I recall, approximately. But they're being used at venues, and the company has launched their version 2 of that product as well. I don't know the particulars of the cost of the product itself, but I have seen that it has been used in public venues as well as universities, and you use a little straw to blow through into the machine, and it can report within minutes whether or not you're positive for COVID-19. So I think it's a fabulous technology. It's still emerging in terms of being able to scale up, but it may be something that is efficacious for us in large venues as well as those public venues such as transportation.
Okay, that's interesting. Here's one about DNA. I'm receiving questions and comments from employees about testing and DNA samples and the potential for their DNA to be studied without them knowing about it or giving their consent. Assuming this will differ per contract and lab, are their samples saved and studied? Not all are destroyed, correct?
Unfortunately, I'm not aware of that, right? In terms of the legalities around storage of these samples for COVID-19 testing, the question is, can samples be preserved and utilized in a fashion other than what it was intended for in regards to the donor's intent? That would be specific to a particular tester and their collection methodology and the releases that, consent forms that they have you sign. So I would look into that particular instance of the samples being provided in the consent, because it very well may be that a vendor is having individuals consent to collection and storage of their samples and utilization for other purposes. Now, we know for the mass seroprevalence data that we've talked about in this venue, that is nationwide, done in partnership with CDC and some private industry laboratories. We know that their blood samples of individuals were used to look for seroprevalence or whether or not somebody had been exposed to COVID-19 and recovered. But that, again, was part of a consent process with the awareness for the individuals participating and donating their blood. So in regards to specificity around this instance, I can't speak to, but do go back, look at the consent, and there you should find your answer as to the storage and testing parameters.
Okay, thank you. And we have time for one last question. It's interesting one. I've heard there are companies training dogs to smell COVID, kind of like dogs smell drugs at an airport. Do you know anything about this? Then the person says, I think I'll train my dog.
That is awesome. So we know this is not the first time in which our canine friends, who have obviously a far keener sense of smell, have been used medically. I am not aware of any peer-reviewed studies utilizing our canine friends for COVID detection, but it's not very far-fetched. There are dogs that are specially trained to detect cancer cells in the presence of some cancers in humans. So with that being said, having a canine assay for COVID detection sounds quite nice to me in terms of the comfort level being decreased in regards to people being tested. So perhaps we'll dig into that one in particular. I find that fascinating, and we'll see if there is any peer-reviewed literature on utilization of our canine friends. Thanks for that question.
Yeah, that gets into the top 10 of questions asked, I think. We're out of time. As always, we don't appreciate a week. I've got a note, at least from one person who's joined us for the first time. So there's always room for more. Thank you, Dr. Harris, for information. We'll look forward to seeing you again next week.
Thanks, everyone. Take care, be safe, and God bless.